Thanks a lot, and welcome to this session on ensuring quality basically outside of Business Central, web services, front ends. We're going to cover a couple of things, but first of all, let me introduce myself. My name is Tobias Fenster. On the business side, I'm a managing director at 4PS in Germany, which is part of the 4PS group, which is part of the Hilti group by now, not to make things complicated. We are a Business Central ISV focusing on the construction industry. On the community side, I'm a Microsoft Regional Director and Business Central and Azure MVP and Docker Captain. And if you want to get in touch, if you want to follow along what I'm doing, you can find my contact information here, including my little podcast. So reach out if you want to discuss anything technology. I'm always happy to get in touch. But with that, let's go straight to the topic. And as I mentioned, the story is about ensuring quality outside of Business Central. So when I handed in this session, at the session proposal process, I was a bit afraid because probably for most of you, at least for me, for the company I work for, Business Central still is front and center. And I mean, we're at BC TechDays, right? So no surprises there. But as a matter of fact, it's not only about Business Central these days. We have the lovely Dynamics 365 products. Don't ask me which logos those are. I just picked a couple of ones at random, so no clue. But certainly there is a lot in the Dynamics 365 world that you also might want to connect to. So that already adds a bit of a complexity. Then it's not only Dynamics 365, but it's also the Power Platform, including Dataverse. So you have things like Power Automate, you have Power Apps, you have Dataverse where you put data and integrate with other systems. So that also is an additional dimension. Then, of course, we have the whole Azure ecosystem, and I could have put probably 150 logos on that, but I just used the ones that we will see in the demos now. So Azure Logic Apps, Azure Functions, VMs, Key Vault. Those are probably some of the more usual things you might use in Azure. Then you might have something that you developed on your own. In this example, it would be a Blazor front end with C#. So front ends that do specific things that you can't do in Business Central, where you're addressing specific user groups or something like this, that can also come into play. And of course, it's 2024, so I had to put in a Copilot logo and an OpenAI logo in here. We won't touch any of that, so this will be an AI-free presentation, but of course, this is also part of the picture by now. And the question then becomes, how do we ensure quality? If we look into the Business Central world, we have a pretty clear idea, I would say. We have AL-coded testing. We have the performance toolkit if we want to make sure that the quality is right. We now have the page scripting tool if we want to do kind of front-end tests. So there, I guess we all have an idea what we can do, what we should do, what we hopefully all are doing to ensure that the quality in Business Central is in the right place. But what can we do outside of Business Central? That basically is the scope of the story that I'm going to tell you for the next 86 minutes. Maybe your approach is like this. Maybe you feel it's getting slightly warmer. Maybe you've been burned now and then, but you're still fine. It's okay. We're in a situation. I can handle that. But maybe at some point this happens where it becomes really uncomfortable. You literally get burned. You may be spending a night or two. You're spending a weekend fixing something where you had no idea that you actually had a problem. So this is something that can happen if you don't take enough interest in quality assurance if you're not sure about the quality of your application. I'm not saying this will happen to you, but certainly it's a better feeling if you have at least some idea that you prevent the worst part of the things that can happen to you. So I'm German, so definitely I had to come up with a definition. This is what the IEEE says. No, just kidding. Of course, we're not going to look at a formal definition, but the idea when I think about quality, and I hope that resonates with at least some of you, is that the foundation basically is that your application works. You need to make sure that whatever you're providing to customers, to users, to whoever you're targeting, it does what it's supposed to do. And then, of course, it also needs to perform. So if it just does what it's supposed to do, but you have more than 3 users and it breaks, then you probably also have an issue in your application. So it's not only about the functionality, but it's also about the performance of your application, the load that it can take. And then on top of that, this is the room is on fire scenario. So if something really drastically goes wrong that you maybe didn't anticipate, or you anticipated but you didn't prepare in the right way for it, this is also something that is part of the quality story. So this is basically more or less how I personally look at quality. But what has changed, I would say, in the last couple of years is that performance has gotten even more important. So by now, depending on what scenario you're running, are you targeting end users? Are you targeting internal people, external people? How patient are they? How willing are they to live with a page loading for maybe 2 or 3 seconds? This could also be the case, where performance is at least almost as important as working, because if your application works, but your initial screen takes 5 seconds to load, no one will see that it works because they will already have left your application. And that means that we really need to consider not only functionality, but also performance, and then kind of the top of this pyramid, what if something goes wrong? How can we understand what that might mean? How can we try to find solutions for that scenario as well? So that is basically the scope what we will look into today. Functional testing to make sure it works, performance testing or load testing to make sure the application performs, and a bit of chaos engineering to make sure to cover the room is on fire scenario. And for all of that, we will also look into automation, because we not only want to do this on demand, but we also want to do this continuously as part of your builds, as part of your releases, as part of nightly runs, as part of weekly runs, as a part of planned experiments, whatever. But you definitely don't want to do all of this manually, but have a way how to automate it. So we will look into that as well. So what's the structure of the following session? We want to take a look at Playwright for functional testing. We want to take a look at Azure load testing, which is using JMeter behind the scenes. More on that later, of course, for load testing. And we want to take a look at the Azure Chaos Studio for some chaos engineering. For all of those topics, I'll give you a brief intro to give you an idea how it works, what's it supposed to do, what we want to do. We will also take a look at a practical scenario and a demo, and that will include the automation part so that you can understand how this works. And then I will also give you some explanation how I've set this up, links to repositories and so on that you can try this at home. Well, basically, my goal for today would be to raise your awareness or to give you an idea what you can do in those 3 dimensions of quality assurance. And if you feel like, yes, this is actually something that we should do in the company or whatever, you have a problem where this actually might be a solution, then I also want to give you an idea how you can quickly start this up, so you don't have to start from scratch, but you can get a bit of a quick start to play around with those technologies. The questions I hope to answer in the end, but we're working with Azure, and as you've seen maybe in some of the demos before, Azure sometimes can be a bit unreliable, especially the Azure portal. So there might be some situations where I need your help and will open up for questions because Azure is loading. And then you can, of course, also ask some questions. One last comment before we dive into it. Typically, when I do sessions, this is based on a lot of experience in production scenarios. And for the topic of today, that is actually not the case, to be honest. So if you, in the end, ask me, please show me the strategy for managing your chaos experiments over the last 5 years, I won't be able to show you that. Partly because Chaos Studio is not 5 years old, but also because I don't have that experience. So just a brief caveat on that. But with that, let's get started. And first of all, let's talk about functional testing. Let's dive into the side where we make sure that it works. As I mentioned, the idea of functional testing is that we make sure the application provides the expected functionality. So whatever you want to deliver to your user, whatever your user expects from you, this is what we want to provide with functional testing. You probably want to validate your core processes, your core features to make sure that everything that is really crucial for your application, for the value that you're delivering, actually works. You want to look at the status, especially for UI testing. You want to make sure that the things that are should be visible are visible, that things that should not be visible or available are not available. You probably want to check the results. So you're not only going to go through the flow, through the process, but you also want to make sure that the result is the right one or that it fails as expected, which can also be the case. And you probably want to do this not only with a specific data set, but with various ones. But I guess that's obvious. Key requirement for that is to have an understanding of what to test. A great idea for that is to have one or actually multiple test plans. And if you want to learn more, this is something where my colleague Luc van Voet can definitely help you. He's a great great teacher and very knowledgeable on that topic. So if that's an interest, I just want to briefly basically point at him. So what we're going to use today is a tool called Playwright, which is an open source framework created and maintained by Microsoft, but open source, that allows you to do cross-browser testing for browser-based applications and workloads. It could either be Chromium for the Chrome and Edge family, WebKit for Safari or Firefox, so basically more or less the whole web world is covered there. You can do cross-operating systems, so whether your clients are on Windows, on Mac, or on Linux, you're covered. And you can define the tests in any language that you want, or not in any language, but in a lot of languages. And we're going to use Node.js today. So that is what you can get from Playwright. And as key features that we will look into, we will see code generation. So we will record the test, but it also generates code, and actually very readable and very maintainable code. We will use the Playwright inspector, because when you test the UI, you need to figure out where the different elements are on an application, and that's what the inspector helps with. We're going to take a look at the trace viewer that helps us to understand when a test goes wrong or something fails, what actually is the problem. And we will see easy headless execution in pipelines, so that you don't need a browser, but you also can run this in a pipeline environment. So this is basically the core structure of what we have in Playwright. The core of it is here. Playwright itself, this is the engine that we can run, either, as you can see here, from an editor or from the command line, or in fact also from a pipeline. And you can also already see the logos here. This can both be Azure Pipelines or GitHub Actions or Jenkins or a lot of things that can actually run Playwright. Then we have another Azure service, of course, which is the Microsoft Playwright testing service. And this is just good for running higher workloads in different environments. So you can see here a Linux configuration, a Windows configuration, different browsers, and so on. But what we're going to do today is we're going to directly use Playwright to call our application under load. So we're going to skip the Azure service in that case. This is basically how Playwright works in general, and what do we want to test today? What do I have as an example? It's a little pizza ordering application. It's based on the Blazor workshop by Jeffrey Fritz, and when I say based, that means that I changed the logo, as you can maybe already see, to BC TechDays, and I made one little tweak to show you something specific when recording, but otherwise I deserve exactly 0 credit for that application. Has been created by Jeffrey, and you can find it on the web. It's a non-trivial dynamic website to show you a bit of interaction as well, and we're going to do some recording, coding, and playback. And with that, let's dive right into our demo. And I have my demo VM here. So this is the beautiful app. You can see here, I can register, I can log in, I can order pizza, I can give it a size, I can add some topics, I can order, and so on. But of course, we don't want to use the application directly, but instead we want to record the tests. And in this case, I'm basically starting from scratch. So you can see here, I basically have an empty folder in Visual Studio Code, nothing in here. But what I did is I already installed the Playwright test extension of VS Code. And what I can now do is I can say install Playwright, select the browsers that I want to use, and make sure I also enable the GitHub Actions workflow, so we're ready for CI/CD already, and then I click on OK. I've done this before, so it already has the basics installed. If you do this at home, it probably will take 5, 7, whatever minutes, but then it has Playwright installed, and what it doesn't say, but actually does, it also creates an example project for us that we're immediately ready to go. So as I have now talked enough, we should have the structure in place here. So I already have an example, and then I have a predefined test that I can use here as well. But as I mentioned, I don't want to write code in this case, but instead I just want to record it. So I go in here, say record new, and it says CodeGen is starting. I'm getting a browser, and I can now use this to interact with my application. So let's copy the URL, put it in here. And this is now loading the application, and this step has already been recorded. So first of all, I want to register. Need to make sure I type this correctly because I want to log in a second again. Oh no, this is the password. So I have registered. Typically, I would get an email. I would need to confirm, but because this is a demo environment, I just get a link here to confirm. And it says, yes, thank you for confirming. You can already see with the colors that Playwright is interacting with this and selecting environments and showing me how I can address those elements. So now I go back in here. I hit the login. Need to use the same email address and hopefully still can remember my password. And here we are logged in. And now, of course, I want to order some pizza. Let's take the bacon one, make it a bit bigger, add even more bacon, and put it on a silver platter, because why not? Slightly expensive, but anyway. And then let's use the mushroom one and add some bell peppers. I don't care. So this is my order. I click on order, put in my name. Of course, I'm here right now, so I want to order it here. I'm in Antwerp. Belgium is not really a region. But anyway, enter a postal code and place this order. And now I get the confirmation that the order is here, and I can sign out. So let's stop the recording and see what has been generated. And there you can already see that the code that is created by this recording is not that bad. I mean, you probably would put it differently if you would create this from scratch. But on the other hand, for generated code, it's not that bad. I can clearly see what it does. It goes in a place, it selects a link, it clicks somewhere, it fills in information, it hits tab, and so on. So what we can do, and I want to do one little thing in advance, which is make the default timeout a bit shorter. The default is 30 seconds, and that means that we would have to wait for quite a time. Let's do this in 5 seconds. So we just run the test here, and it works until this moment. And now I get an error because, okay, my confirmation link that you've seen before, where I confirm my email, doesn't appear. I had the show browser setting on the left here activated, and that means that Playwright opens a browser in here that exactly does the test. And you can see here, okay, we get an error. Of course, the username is already taken, so I can't use that one to register again. So we need to randomize the thing a bit. Fortunately, I'm in TypeScript here, so I basically have the full capabilities of a programming language, but I don't want to struggle with the syntax, so I put this in here. And where did we use it first? Here. So I'm just going to random generate an email address, put it in here, and oh no, the registration was above here, and use the same email address here. Of course, I could also randomize the password, but no need for that. So let's run the test again. Now we have a random username that is taken, and it blocks here. Maybe you saw it blink a bit here. The reason for that is that there is some JavaScript, TypeScript, whatever, that is running in the back end, in the front end, and is loading. So because I'm immediately clicking, this doesn't work. Now I could do some tricks waiting for the JavaScript or something like that, but let's use the stupid version for now. And that is that we just wait for a timeout, and 2 seconds should be enough. And I'll run this once without a browser, so you see this also works. So let's run the test again. And you can always see here how long did the steps take, what did it do, and it ran through and finished. So this time we went through the whole process with recording, with a couple of small adjustments, but then we already have our test in place in very readable, very maintainable code. Now, of course, this is the very the very basics. I just ran through the process but did nothing else. What I probably also want to do is I want to ensure that some things are visible that I expect to be visible, and on the other hand side, things should be not visible that should not be visible. So the easiest example of that is the login. After I log in, I want to, of course, see that I have been logged in, and then the login button or the register button should be invisible. How can we do that? I can run the trace viewer with my test. That's one way, and I find it very easy. So if we just run the test again, I now get an additional window. That's not directly the browser, but I can see on the left here, once the test is finished, the actions that have been run, and on the right, I can see the application, how it looked like. And the test went through, so now, let me scale that up a bit. Now I can also see here on the left the different steps that has been taken. And if I click on such an action, I can always see, okay, what is the action that has happened? What was the status before the action? What was the status after the action? So I can directly follow along and see what is actually happening. So before the login is happening, let's see, probably here, and then we are logged in here. Let's say we want to make sure that the logged in thing is visible. For that, I can use the locator here, collect it, and then click on that one. And I hope you can see with the colors how this is changing. So I can just see in the mouse over what is used, but I can also let it generate the code that I need to locate that element down here. And I can easily copy it and then go into my code after the login here, and say, no, not assert, wrong language. I expect on the page to find this element and for it to be visible. Is it visible? Yes, to be visible. And again, now we have the generated username here. Of course, in the next test, that will be something different. So we need to use our email variable again. Put it in curly brackets. And close that one. So now we know it's here. And on the other hand side, I want to make sure that the registration button is no longer visible. So I can just go here where it was visible, use the same locator action, find my little login link, and copy that locator again. Go in here and say, I will expect on the page this particular locator to not be visible. So now I'm checking, has the login worked? Does it show the logged in user? And can the user no longer log in because he or she is already logged in? Again, let's disable the trace viewer because then it's a bit faster. Run the test again. And it went through, so it has validated that it's there or not there, and we can go ahead. So what happens if we run into a problem? For that, I want to show you the element again. So if we switch this to not, we know that it will fail. But with the trace viewer, we can exactly see what happens. So it's going through the test and goes here. So we're now in the place where it should fail exactly. And then I can use the trace viewer, find the place where it failed, and see, okay, I have the locator, it's marking, this is actually visible. I said in the code I expect it not to be visible, so this is where it fails. So let me change this back. This gives you an idea while you're developing your app, your test. If you're doing the assertions or the expecteds, you can easily identify what goes wrong, if anything goes wrong, using the trace viewer. And if you've seen before, we can also easily use the browser if we want to immediately interact with the application and go to the place where something goes wrong. So this is basic recording. What else did I want to show you? Yes, of course. Now we have hard-coded all the data, but typically that is not what you want. You want to use some maybe random data, or maybe you want to use data that is stored somewhere. And the easiest example for storing data somewhere that we can use during a test would be a CSV file. So let's put in some pizzas here. And as you've seen, we also need some toppings. So let's create a toppings file and put in toppings here. And I have created a little snippet for the code that I need to put in here, which is the CSV parsing. For that, we need an additional dependency, a package that we need to install, but that will be very fast. Then we need the imports. That is basically just standard TypeScript here. And with that, we have the code in the pizzas array and in the toppings array. So now we can go in here. Let me close that so I can see a bit more. This is our first pizza. So let's use pizzas, and I called it selection. You can see here the header, basically, this is then reflected in the object that I get. So I have my selection here. I have pizzas, and I called it size. And then we have the toppings. Did I call it selection? Yes, I call it selection. And put that one in here as well. And then we have the third one down here. We have the second pizza. And we have the second size. So if we run this again, and I want to enable the trace viewer because I want to show you something here. This is now no longer running with hard-coded data, but instead this is now running with the data that has been read from the CSV. And of course, this could also be a web service or random generated, or even a request to Business Central where you could collect the data that you want to test with. But what is interesting, and that's what I wanted to show you here, if we now take a look at the way how things are located, for example here, you can see the locator action that I'm getting here shows me what has already been resolved from the sources. But if I also take a look at the source tab here, where I get my the source of the test, I can see that this is actually taken from the array. So I have both views. I can see how it looks in my source code, and I can see how it looks when it actually has been resolved. Okay. That's what I wanted to show you, I think, for creating playwright tests. Yeah, one last thing. If we take a look at the test that has been generated, you see also some ugly elements here, like this is the fourth child of a div, this is the fifth child of a div, and so on. And if you compare this with the place where I put in the Kinepolis, this one is fetched by a label. And the reason for that is that in the source code of the application, so this is the pizza application, a label is defined on line 1, and for example, on line 2, there is no label, or in a city, there is no label. So if I have access to the source code of the application that I'm testing, I can easily make that change. But if I don't have, I might have to point it out to some other developer. And what I can do for that is I can go back in here in my trace viewer and find the place. And now what I can do is I can pop this out into a real browser window, and then I can use the developer tools to actually inspect the application under test. Again, I have the sources for that one, so in my case, I probably would just look at the sources. But if I don't have that, I can also use the full developer tooling to take a look at that here, and then see, okay, there's a label defined on that one, but there is no label defined on the other one. Now, the point is, the trace viewer is not only generating images that are highlighting the stuff, but this is actually a snapshot of the application as it was at that stage, and I can interact with that snapshot using developer tools. So even if something is running in a pipeline and I collect it, as we will see in a second, I can still interact with that application. It's not just images, it's a real snapshot that I can do something with. So as I mentioned, automation, that would be the next step. It's very easy to throw down your clicker. Hey, I'm back. It's also very easy to set up automation for pipelines in that scenario. I put on the link here if you want to do this with Azure Pipelines or GitHub Actions or other tools. But it's extremely easy for GitHub, because if we take the sample project here, you can see, wrong VS Code window, that one, it already has a pipeline or a workflow in GitHub Action language defined for me here. Very easy. It just installs dependencies, it installs Playwright, it runs the test, and it uploads the actions, so the results basically. So if I would just commit this and push this to GitHub, because it triggers on all pushes to main and master and all pull requests to main and master, it would immediately spin up that pipeline. I don't want to take the time to do that, but I want to show you the result if I find the right window. Exactly. So this is basically what I did. In that case, I still had an error, but that's actually more interesting. But to set up that pipeline, I didn't have to do anything but just commit and push. The rest worked automatically for GitHub, and it's not terribly complicated on Azure DevOps as well. So what went wrong here? I can take a look, and then I can see some trace output that I can probably already use, but it's even easier than that. If I go take a look at the upload artifact step here, I can download that artifact, and that's a zip file. And if I expand that into my demo workspace that we've just now been using, which is in demo 1, oh no, I want to extract, I don't want to chase the path. Let's do that here, demo 1. Extract that. Yes, replace the files. Then I have it on my machine. And if I go in my Playwright environment, I can now say npx playwright show report. And this is now taking the data that has been exported from the pipeline. And I now get the tests. I can see that they failed. I can take a look. And now I'm back in my trace viewer as we've seen before. So now I can find the place where it failed. The locator is trying to find the slider, so somehow the JavaScript in that place didn't work, and I can go ahead and take a closer look. But that means even if I run it in headless mode, even if it's running in a pipeline, I still can use the same tools as during development to figure out what went wrong and how I can fix it. Okay, that's it for Playwright. If you want to do this at home, you can find the application on the GitHub link here. It's easily runnable in a dev container, so you basically just open run and it should work. Then you need to install Playwright in Visual Studio Code. As you've seen, run the same install that I did. Make sure you don't do that in a dev container, because that actually doesn't work, as it needs to interact with the browser, but instead do this natively. And then you can get started as we've done. If you just push to GitHub, your CI setup on GitHub Actions will already work. So if you wanna get started, this would be my recommendation. So much for functional testing. Let's switch to the next part of our little triangle, which is load testing. That means that we want to make sure that our application can handle a specific load, a number of users, a number of requests, whatever, giving a specific number of resources. So whatever your backend is, you can probably scale it. You want to make sure that this is the scale at which you want it to work, and also that it responds within a given time with an acceptable error rate. Whether that error rate is 0 or is maybe slightly above also completely depends on your scenario, of course. What you want to test is probably, again, your core processes, and you probably want to test with expected realistic scenarios. I mean, that's the easy one. That's the no-brainer. With the load that you want to, that you will expect, You want your application to work, so this is certainly something that you want to test. But you probably also want to test with more than expected, because who knows, maybe you're more successful than you think, or maybe there's a bug in a client, or whatever might cause excessive load. This can happen, and you at least, I think, should have an understanding what breaks. So what's the actual bottleneck? If I run into that situation, can I just scale up my infrastructure and it works? Or will we run into an architectural problem and we will get logs and deadlocks or whatever if we have too many users? So if we go in that situation, then we have to re-architect our whole solution. Load testing gives you an opportunity that you can test that and be prepared for that situation when you run into that particular problem, so that you're then prepared. What you also probably want to do is you establish a baseline and compare against that baseline, because then you can use it in your tests. As an example, maybe it's completely acceptable for a specific load that it takes 1 second to return, and in your builds, you always see 300 milliseconds as a return time. So now this is your baseline, and if you test this tomorrow, maybe it goes up to 600. If you only test against your limit of 1 second, that would still be a test that is okay, but actually you probably want to understand why it went from 300 to 600 milliseconds. So it's important to both test against the limit that you have, but also test against the baseline to make sure that whatever you did in your development didn't completely mess up your performance. From a functional perspective, you probably want to test the critical aspects. Like I mentioned, the login screen should load very quickly, otherwise your users probably will leave. Or there are times when users are probably more critical, like the payment, like posting. That also should probably work as fast as possible. And then you have, you probably know what the resource intensive parts of your application are, like complex calculations, like data analysis, like batch writing of data. And that is also something that you should test to make sure that in those critical areas, you're also fine. What are we going to use for load testing today? I'm going to use the Azure Load Testing Studio, which is a cloud-based load testing service. For once, cloud absolutely makes a ton of sense. You have more or less unlimited resources, so if you want to create a lot of load, that's perfect. It can generate load on demand with very little setup, and you can even geographically distribute it. So if in real life you maybe have the majority of your users from Europe, but you also have a substantive part that is coming from Asia and a substantive part that is coming from North America or whatever, you can also simulate that easily with Azure Load Testing. It has a nice quick start feature that we will use in a second for simple to medium scenarios where you basically have to, or you can stay completely within the Azure portal or within Azure Load Testing. If you need more, and we will also do that, you will need JMeter, which is a very established framework, and you have that to integrate with Azure Load Testing. For creating your tools, you can either use the portal, as we will do, or you can use the Azure CLI or infrastructure as code tools like Terraform or Biceps or things like that to create your tests. How does it actually work? As I mentioned, we have the quick test part. So that would be if you just put in a URL amount of users and you go ahead. And this will in turn create a JMeter script, or you already have a JMeter script. So that would be the second option, but behind the scenes is always a JMeter script. This will then trigger a test engine, one or, as you can see here, multiple, a lot, and that will generate load towards your application. On this example, the backend, of course, also is on Azure, but it could theoretically also be something else. But if we, for example, select a virtual machine on Azure that is targeted, then we can also use, as you can see here, the Azure Monitor to collect the performance data. So we're not only generating load towards the application, but we also are getting the information how our backend performs. Is the memory overloaded? Is the CPU overloaded? What is actually happening? At the same time, it's also collecting metrics on the client side, of course. How fast are the responses? How many users have been generated? Does the client maybe even have a performance problem? Things like this. And then in the end, it's collected and combined in that dashboard that we will see. So you have both the view of your client side, users, response times, and so on, and your server time. How does my backend actually behave? And again, we can use this automated from Azure DevOps or from GitHub. And of course, we can use this manually, as we will see in a second. So what are we going to demo, or what are you going to see? I'm going to demo, you're going to see. I have created a little service to convert a PDF into a PNG, so an image file. Basically just takes a PDF and using image magic, it's going to convert that. And I have put it both on an Azure function and on a virtual machine so that we can see how those different backends behave and the performance they give us. The code is running in a container, as I mentioned, on Azure Function and on an Azure VM, and we want to generate some load. We want to use it to find out what the bottlenecks are, and then we're going to scale the infrastructure, or actually I've already prepared that. We will see the results of that. So let's go into the second demo, and what you can see here is an Azure load testing resource, which you need on the Azure portal to get started. And I also want to show you the application, which is the little PDF conversion service. So as I mentioned, it has a simple GET request that just echoes. So if we don't put in a parameter, it will just say hello TechDays. If we put in a parameter, it will return that name. And the actually more interesting service that we will look at more is the PDF conversion. That one collects or checks if we have sent in a PDF. If yes, it then uses image magic to read that PDF, convert it into an image vertically ordered, and return that image to the sender. If not, it will send a bad request. What does this look like? As an example, it's also running here locally. So the echo just returns with 41 milliseconds. With the parameter, it has the exact same performance. If I send in a small PDF, you can see that one here. That is what comes as a sample with image magic, so I just use that one. This is the PDF, and this is how it is returned from our service. And to generate more load, I also used our little company brochure over here that has a lot of images, a lot of content here. And if we send that one, it will take roughly a minute to convert that one into an image. So I won't wait for that one, just show you the result in the end. So it can also handle bigger requests. But to go back into the Azure portal, I'll take that URL with me because I will need that in a second. So I can go in here into the tests, say I want to create a new test, a simple URL-based test. I can give it a name. I can give it a description, function backend, for example, immediately run it. And if we disable the advanced settings, then all I need to do is put in the URL, say how many users I want, how long it should take, and what the ramp up should be, and then I can basically review and create. So just running an amount of gets is literally just the number of clicks, and then I get the results. If we enable the advanced settings, it allows us to do a bit more. In that case, I can add an input file if I want to, but I also can define a request. So this would just be our simple get again. API echo. I can select different HTTP methods. I can add query parameters. As you've seen, the echo one accepts a parameter. I can set headers. I can do something with responses if I want to use them in subsequent requests. And then I can set additional variables like environment variables or secrets or certificates if I want to do some, or if I have the endpoint secured. I need to set up the load again. And then I can see here, okay, this is expected to immediately go to 50 users, run for a minute, and then go back to 0. I can define some metrics that I want to accept. So, for example, if my response time goes above 1 second, then I want the test to have failed. If it's below 1 second, then it doesn't have failed. Or I can have an error percentage. For example, if during 60 seconds I get 90% error responses, then something is wrong, then I don't want to continue with my test and just stop it. So those are the things that I can define here as well. It would take a while to create and run that. So what I have done instead is I have already prepared that to show you. So here, this is basically the same thing that I've just created. Once run again against the Azure function. So you can see here, we have an average response time slightly below 1 second. It ran for a minute. You can see how the response times have changed in between and so on. And if we check the same for the Azure function, for the virtual machine, you can see that it has taken roughly 10% of that, so not even 100 milliseconds. I can also again see the response time, how it has changed, the requests per second, and so on. And here you can also see the server-side metrics. So I can see that, for example, my CPU was basically not bothered at all. So those requests didn't matter. Of course, makes sense. Just returning something that has been put in shouldn't create any CPU load. But this is a way how I can measure those systems. So let's do something a bit more complicated, which is our PDF conversion. As I mentioned, for that we want to use JMeter, which shows up in a funny way. Let's see. That's better. So this is the way how I can do more complex things. For example, we now need to upload a PDF. So we need a post with a PDF, with a file, and that's not possible directly in the portal. So what we do here is we define a request, and that one is using some variables for the protocol, for the server name, for the port number, because those are different between my two different backends. It has the post, as you can see here. It has the path, which is the API conversion, and it uploads a file, which is, in this case, the 4PS brochure. If I take a look at my small request, that does exactly the same, but it uses the snakeware PDF. So with that, I have defined two requests that we're going to run, and the load distribution between those two is set up here. So you can see that I have only one thread, basically simulating one user for the big one. And for the small one, I have used 7 threads, basically 7 users. So that means if we run this test, we're going to have 8 users. One of them is creating a big request. 7 of them are creating a small request. And of course, I can, in JMeter, do a lot more complex scenarios, things in parallel, sequentially, and so on. But this is just for now to give you an idea. You have seen those variables, the protocol, the domain name, and the port. And as you can see here, we're getting them from environment variables, because that is what we can put in from the Azure load testing side into our JMeter test, which will interpret this and then call the right backend. So if we want to do this, I'll go back into my tests and say I want to upload a script this time. Again, give it a name and so on. But then I immediately get the upload, where I can now upload the JMeter script that I have created and let that run. Again, those would be running 10 minutes, so I have prepared this here. So for example, let's take the first one and show you the setup. This is basically the same screen that I would have seen when creating it. So you can see here, I've given it a name. I have uploaded the JMX file, which is the test description coming from JMeter. We, of course, need our 2 PDFs that are to be uploaded, so I need to add those as well. As parameters, we actually should have environment variables. Let me check again. Let's see. Okay, either that was a glitch or I set it up in the wrong way, but here you can see the protocol, the fully qualified domain name, and the port, because that's what's different between the VM and the Azure function, and I need to put them in as environment variables, so JMeter can use them, put it in variables, and then I can use the variables in my test. Nothing else here. The load, I have in this scenario added 2 engines. What an engine means is that it runs whatever I have defined in my JMeter test. You remember we had those 8 users, one big and 7 small. If I run this with 1 engine, then I get exactly this. If I run it with 2 engines, then I get 2 times that amount of load. So basically, then I get 16 users, 2 running big requests, 14 running small requests. Here, I could also do some regional distribution. I didn't do this for my test case. I added some test criteria. So the big one I expect to return within 90,000 milliseconds or 90 seconds. And the small one I expect to return within 1.5 seconds. Not every time, but in the 95th percentile. So in 95% of the cases, this criteria should be met if the test should pass. Also, I want to auto stop it if it runs into 90% errors within a minute. And now for the monitoring, I can define which backend components I want to monitor. So in this case, it would be the VM. In the other case, it would have been the Azure function. And I can even set up which metrics I want to monitor. So for the virtual machine, I have CPU credits, disk read and write, CPU percentage, and memory, so that I have an idea what happens on my VM while my test is running. So if we take a look at the tests here, you can see when I ran this first, it successfully went through, so the status says done, but it also shows that the test result is failed. Why is that? If we take a look at that one, we can see it ran for 10 minutes. It had a response time of an average of 1 second, but you remember that we had 2 different ones, so we need to take a closer look at that one. It had no errors, so that looks good, but if we scroll down a bit, you can see here the small requests returned within 1.2 seconds, so that would be below our limit, but the big ones took roughly, what is this, 163 seconds, so almost 3 minutes. That is above our threshold of 1.5 minutes. So this time it failed because it generated too much load. Why did it generate too much load? Again, we can take a look at the results here, and because only the big ones failed, I can also filter here. So I'm only interested in the big ones. And there I can see, okay, a number of requests ran, but they were too slow. No errors. But if we look into the back end, we can see the disk is basically idling. This is only 8 disk write operations per second. That should be doable. But we can see how the CPU immediately spikes and goes up to 100% and then leads to not enough performance. So what we can basically see that in that setup, with that amount of users, that amount of resources that we gave to the backend, it's not enough, and we don't have enough CPU. If we go back out here to all test runs, you can see that I did a second scale up, which added more CPU. And in that scenario, it worked. The small ones got up to basically half a second, and the big one got down to almost a minute, but below our threshold. So in that one, it's fine. As I mentioned, it's also always interesting to take a look at the different results. So what we can also do here is in the all test views, we can take a look at trends and mark one baseline. And let's say that the middle one is our baseline. And then we can see the different results here. So basically the dotted line here is our baseline, and you can see the first one did less requests. Of course, the second one, which is our baseline, was exactly here, and the third one went up. You can also see the response time here, which went down basically more or less linearly. I also scaled up the CPU linearly, so this seems to be a problem that we can solve by just throwing more CPU at it, and then we are fine. I also have error percentages and throughput and so on. And the graphical view, of course, is nice if you only have a number of results, but it also has a table view that shows you what is your baseline and how the differences are. So if we, again, for example, look at the response time, middle one is our baseline. The first one was slower. The last one was a lot faster. So this is also a chance where you can have more test runs and compare them in a visual way, that you have an idea what actually changed between those test runs. I could now also look into the function, but looking at the time, that won't add too much value, because basically it does the same. It just has worse numbers, but that's it. Let me check what else did I want to show you. Of course, the CI/CD story for performance testing as well. Again, it's quite easy to set up Azure pipelines and GitHub Actions. I've put the links on here if you need the documentation. And we will look into Azure pipelines this time. First time we looked in GitHub Actions. The only thing to be aware of, because that otherwise just runs into an ugly error, is to install the Azure load testing extension that you can find for free on the marketplace, and then your Azure DevOps organization is ready to run performance tests. Oh no. I didn't want to stop the presentation, but I did. No. Try again. Here we are. Go back to the demo. So what we have here in our test view directly in the Azure portal, I can select one of the tests and say set up CI/CD. This pops up an integration with Azure DevOps where I can select the organization. I can select the project. I can select the repository, the branch, and a folder if I want to put it in a subfolder, and then I can click Create Pipeline. This takes a number of seconds, so again, I have already prepared this. This is the result of the pipeline as it appears. As you can see, the first test run has also failed, and I want to show you why. So you can see what it immediately puts in is, and I'll zoom this in a bit again, what it immediately generates is a file that describes the test case in YAML. So you can see, for example, our instances. You can see the failure criteria that we have defined with the 90 seconds and the 1.5 seconds. You can see the environment variables and so on. So all of this is here. And then we have the actual pipeline definition, a very easy one. It just knows which Azure subscription and test configuration it should use, and in the end publishes the results. And this is our actual JMeter file, XML, but yeah, if you take a while, then you can also understand that. But still it fails, and the reason for the failure is that we also need our PDFs that were uploaded before, and we need to reference them. So this is something that the Azure portal is not automatically picking up. If I show you the working configuration, you can see what I did is I just uploaded one PDF and the other PDF, and also I added those as configuration files, and then Azure DevOps knows that it should also upload them and put them in the file, and then the pipeline run actually works, as you can see here. So this is my pipeline run, and if I take a look at the results, I can see here, okay, those are my test criteria. I would have expected, or it would have failed with more than 90,000. It only was 54,000. It would have failed with 1,500. It only was 390, so my test has passed. I also get some more information here. So on the big one, on the small one, the average, response times, and so on. So I can take a look at that here. And I also have artifacts published here. So if we go into the published artifacts, you can see the results here, which has a report and then all the detailed results as CSV. So even after the pipeline run, I can also take a very detailed look at what has happened. So again, yeah, quite easy to set up. Just a couple of buttons that are pushed in Azure DevOps, in the Azure portal, and then I have my Azure DevOps pipeline set up. And as you've seen in a YAML file, if you want to integrate this into your existing pipelines, that's also quite easy to do. That, I of course also want to share with you how you can set this up at home. You have the URL here for the conversion service, either as an Azure function or as a VM. There are scripts, the create Azure infra scripts to create the VMs or the Azure functions, depending on where you want to test. There are the load tests in a load test file, and there also are shell scripts to create the load tests, so you can also see how you can automate that. And then if you want to install JMeter, it's a free download, but you need to make sure to have Java installed because it's a beautiful Java application that you can run, as you've seen here. So let's move on to the last topic, which is chaos engineering. And as I mentioned, the room is on fire scenario. So basically, what happens if something completely unexpected, something drastic goes wrong? How does my application behave in that scenario? What you want to validate here probably is, again, your core processes, your core features, to make sure whatever you really rely on in your application actually works, even if something goes wrong badly. It also helps you to test your resiliency of your application against the things that shouldn't actually happen. So I think as developers, we typically try to also do that. But if we can test it in real life, if we can introduce some problems into our environment, into our infrastructure, that helps us very much to validate if that actually works. And then, of course, we want to make sure that we have an acceptable fallback behavior. So if something goes completely wrong, I don't want to see an ugly exception page, but I want to see something where the user at least has an idea that politely says sorry, or even has a fallback to some kind of limited functionality that I can provide. The interesting thing is what to test, because the things that you know about that you expect to go wrong, you probably have already covered in your code, right? So you can still use chaos engineering to actually introduce the problems so that you can make sure that your code really does what you expect it to do and keeps doing that in a continuous way, because you can repeat it in your pipeline runs. But you can also use it to try some things that you don't expect to happen. And then the problem is, okay, how do I know what to test that I don't expect to happen? So you can see that this is a bit tricky. But anyway, the tool gives you an opportunity to just throw a load of problems at your infrastructure, at your backend, and basically see what happens. What we want to use for that is the Azure Chaos Studio, which is an application that allows you to do experiments, which is why they call it experimentation platform. And it allows you to introduce faults and stresses. A fault means that something completely goes wrong. A stress is, for example, as we will do, I want to introduce 95% load on my CPU, so we can figure out what that means, and the same, or what that causes. And the same for disk, the same for memory. It's a managed service by Microsoft. You can use it to spin, or you can spin it up in the Azure portal to run your experimentations. And you can, of course, design and run your experiments with it. Key features are that running the experiment actually means causing that issue, causing that problem on your infrastructure. That's very important, because sometimes in the documentation they say something like simulation, and that might cause you to understand, okay, I'm only simulating the problem. That's actually not true. You're introducing that problem. If you introduce a service shutdown, that service will get shut down. If you introduce an unavailability, that service will not be available. So you really have to think a bit about where and when you want to do this, otherwise you might cause real problems. That's also the reason why it has multiple security measures, that you make sure that you're really only causing this on the resources where you want to cause that. And the faults that you can introduce are either service direct, which means that a service is directly influenced. Again, shut down a VM, shut down a virtual machine scale set, make a key vault unavailable. Or it can be something that is agent-based, which means that you have an agent running on a virtual machine, and that is causing whatever problem you want to simulate. Again, for example, a CPU load that goes up. And it can be used both in shift left, so early in development scenarios, and in shift right scenarios where you want to test your production environment, but more on that later. So how does this actually work? How does the stack for the Azure Studio look like? We have, as I mentioned, either the Azure portal or a REST API that can be used to trigger and to define those experiments, which is using the chaos provider. Then we have the agent-based faults here, and those, as you can see, are running on virtual machines and need to introduce this agent and tell that agent to create load, to create stress, whatever. And then we also have service direct faults, and those directly talk to your Azure service infrastructure, shutdown, whatever. And on top of that, of course, your application, your code is running, and that is then influenced by the problems that are introduced by the Chaos Studio. What you define in Chaos Studio are called experiments, and those contain those faults that I've just talked about, which are available through the fault library. So this is the general structure of how the Azure Chaos Studio works, and we will immediately take a look at it. What I have prepared is a little web application that calls a backend, a weather forecast backend, but that one is secured by an API key. That API key is stored in an Azure Key Vault, so whenever I want to call that third-party API, I need to fetch the key from my Key Vault, store it somewhere in memory, and then use it later. But what we want to introduce is just an unavailability of the Key Vault. What that basically means, my application is relying on that Key Vault, but I take it away, what happens to my application? Let's take a look at that. So first of all, this is the beautiful weather application that shows me the weather forecast for Antwerp, of course. What this does is, I need to make this probably a bit bigger. It has in the startup, a configuration that adds an Azure Key Vault, as you can see here. Basically, it connects to an Azure Key Vault to fetch configuration items from that Azure Key Vault. And when we call the backend here, we are getting the API key and we're getting the configured city. So whether are you actually going to fetch? And then it calls the backend over here. Using that information, it checks if the response is successful. It checks if we're actually getting something. So it's kind of secure way to implement that backend call and show the response in the application. It also has a little reload button here, which refreshes the configuration and the data. So basically, whenever my API key maybe is no longer valid, I can change it, click that little button, and it will refresh. Or I can use it, and that's what I want to briefly show you, to change the city. So if we, instead of Antwerp, put in my hometown, and I want to make sure that I didn't mistype, no, Ulm in Germany, put this in, and go back into our application and refresh, then now we are getting data from Ulm. Okay, so this works as expected, but what happens if we introduce an unavailability? And what does it mean if we introduce an unavailability? Let's go to the Chaos Studio. And the first thing we need to do is we need to define the target. Remember, we're actually introducing the problem, so we really want to make sure that we're only targeting the resources that we want. And for that, I can try to find the key vault over here that we used, and you can see I already have enabled it because it takes a minute or two loading, so I didn't do that, but I could just click on enable here and then it would be enabled. Now we want to create an experiment. And the experiment is going to live in the right resource group. It's the key vault unavailable, hopefully typed like this, experiment. It needs permissions, and I can automatically create a role for that, or I can do that manually if I'm even more security conscious. And then I get the experiment designer, which has steps. Steps are always executed sequentially, and branches are executed in parallel. So I can both have sequential and parallel execution here. I'll keep the names and just add the fault, which is the key vault deny access. You can also see here, this is basically the library of problems that you can introduce. So there's quite a number, and that number is also continuously increasing. And let's do the deny access. I want to deny access for 10 minutes, and now I need to select the target. Remember that this is what we had to enable in the previous step, so I only have one key vault. I can either do that directly, or I can write a KQL query if I want to dynamically select the resource that I want to target. Let's add that here. Review and create. Create. And it's creating. First thing it creates is that security role. We can take a look at that. So you can also understand which permissions it actually gives. That's especially important if you want to run this in a pre-prod or even a prod environment. Then you probably really want to understand what is happening here. So you can see the actions and the scope, which in this case is the whole resource group. So while the test creates, it already has created it, perfect. Go in here. So this is now our little experiment that is making the key vault unavailable, and I can start it. And refresh, and then it says pre-processing and so on. And while that loads, I want to briefly go back into the key vault and show you what actually happens in this case. We have a networking configuration in here, and the default networking configuration is that public access is allowed, which is why I can reach it from my application and can talk to it. Now, once the experiment starts, let me open that in a new tab. So it now says it's running. If we now go back in here, you can see it has now allowed access only from specific virtual networks and IP addresses, no network, no IP address is specified, so actually this means the key vault has become unavailable. Oh, this is what I meant in the beginning. It's not only simulating something, it's actually making changes on your resources that you can see that cause the problem that you want to simulate. And now if I go back into my application, I can still reload because this is using a cached version. But if I now were to change the settings, I put in a new key or I put in a different city because I want to change that, and I click on refresh config, now it's actually crashing in an ugly way, an unexpected error has occurred, reload, and I can still reload. So maybe the fallback is somewhat acceptable, but still this is doing something that I probably want to fix in some way. It shouldn't be this error message. Now, of course, if we stop before the end of the 10 minutes, that also takes a second until it accepts the stop. Yes, I really want to stop. Canceling, here we go. And with that, it should reset the setting because now the experiment has ended. Okay, I won't bore you with reloading the Azure portal. Point is, after the experiment has ended, the change that occurs during the experiment, of course, is also rolled back. So you don't have to clean up afterwards or anything like that. That is automatically handled by the Azure Chaos Studio as well. So this was a simple example by just making a key vault unavailable and then doing some manual testing. Of course, I could now have, in parallel, also created a playwright test to test the functionality, have that reconfigure button hit, and then see what happens. But I can also do the same thing as a combination between load test and an experiment in the Chaos Studio, which is the second scenario that I want to show you, where we're basically using the same service as before. So we're still doing PDF conversion. We upload a PDF, get an image file back, and this time we're using the VM-based backend. And then we use Azure Chaos Studio and that agent, because now it's an agent-based fault, to introduce some CPU load. And we've seen now that it performs without someone doing bad things to our environment. Let's see what happens if we introduce some stress into the environment and in parallel run the load test. Now, this is the difficult part. I have actually seen this work, trust me, but unfortunately, at the moment, it's broken. When I tried to do this in the beginning of the week, it didn't work anymore. Still, I want to show how it works because actually this is a bug, and I hope this will soon be fixed. And it's quick that you have an idea what the actual idea is. So in my Chaos Studio, I have an experiment, CPU pressure, that I can edit. And you can see here, I can use it to introduce CPU pressure for 5 minutes with a level of 95. So that means the CPU will be loaded up to 95%. What I should now actually be able to do is add an additional fault, which is the load test. So I can start, oh no, this was the stop. I can start a load test. I just need to put in a test ID and the load testing resource, and then it would put that in. I run it, but unfortunately then an error happens. I didn't get a response yet, but yeah, either I'm doing something wrong than when I prepared it the first time, or there currently is a bug, but I can't show you that at the moment. But fortunately, there is a workaround. And that also is the same as for automation. So again, I want to show you how this works in an automated way, and we can easily, again, create a pipeline that runs our chaos experiments. What that could mean, for example, is that you run this on a weekly basis, where you run your playwright test for functionality, you run your Azure load tests for performance, and then you validate that everything is still fine. Then you start to introduce chaos experiments to figure out if it's still fine, or if then it maybe breaks. If you want to do that, you have to install the Azure Chaos Studio extension that you can also find for free in the marketplace, and then you're ready to set it up. And we can use this as a plan B, because in a pipeline, I can easily both run a load test and a chaos experiment just as different pipeline steps, and then we can see how it works in parallel. The setup is here. So we have this pipeline, which is basically the same as we've seen before, running the load test. So this is just the load test step that you've seen before. I created it with the same setup CI/CD steps that we've seen before, but now I'm also introducing the chaos experiment. I put it as with no dependencies. That means that it runs in parallel. I wait for a bit, actually 3 minutes to start, so we can first see that it performs as expected without the chaos experiment. Then I let the chaos experiment run, which introduces the CPU pressure for 5 minutes, as you've seen, and then in the end, we should see that the load test goes back to normal. So again, what does this look like? We have our pipeline and the pipeline run here. You can see that the load test and the chaos experiment both have run. The chaos experiment just introduced the CPU pressure and then stopped, so no surprises, it has worked, but the load test didn't. And if we take a look, we can see, okay, the average for the small one was 1100, so that's still okay, but the big one took more than 3 minutes, so that one is no longer okay if I introduce that CPU load. And the good thing is that we can also take a look at the results by checking the load test. So the load scenario, the tests, and I used, I think, that one exactly, and this is the test that ran with the Chaos Studio. And if we now look at the requests, you can see in the beginning for the first 3 minutes while the chaos experiment was not running, that one was fine. And then it went down, the number of requests. If we take a closer look, because it's better visible there on the small requests, you can also see the response time here. So in the beginning, it was okay, below 1 second, and then it went up to above 1 second. When the chaos experiment stopped, it went down again. And you can also see the CPU load. In the beginning, it was going up, but not that much. And then the 95% pressure hit, and we go up to 100%. So this is the way how we can combine a load test and a chaos experiment, in this example by introducing CPU load, but if your application is more relying on disk or on memory, that would be easily doable as well. So you have an idea, okay, if everything is fine, my application performs like this. If we introduce some stresses, what does that actually mean? Does it care, or is it a problem for my application? Okay. For chaos engineering as well, if you want to try this at home, you can find the link to the application that is using the key wall to fetch the service key. You can also find the load test here. You have the different scripts to create the infrastructure or to deploy the application, and then you just introduce the Chaos Studio experiments as I've shown you and take a look at the application. That basically concludes the chaos engineering part. And the last thing I want to briefly discuss with you is the question, where should we use this? How should we use this? You've now seen the tools, and I hope I gave you an idea of what the scenarios are that you can use them for. But still the question is, should I shift left? So if we look at the development life cycle, should I try to do this as early as possible? Or should I shift right, which is the idea to do this on an environment as close to production or even production itself, to make sure that that works. For functional testing, that's very easy. Functional testing, shift left as far as possible. The earlier you find a problem, ideally directly in VS Code running the test, that's perfect, because then you still know what you have done probably, what might have broken it. You're immediately able to fix that problem, and the earlier you find the problem, the cheaper the fix is. Once it's rolled out to the customer, it's a lot more expensive to fix the problem, so make sure you do this on the left of that timeline as much as possible. For performance testing, it's a bit more interesting because you can use this on a shift left approach to catch relative problems. Remember the baseline story where we said, okay, I want to have an idea how long should this take during my builds, or maybe how many resources should that take during my builds, how many SQL calls should that be during my builds. That is also something I can catch with performance testing. And then if I run my pipeline again tomorrow and suddenly it's worse, then I know, okay, I have a problem. Maybe I'm still within my limits, but I changed something that has an impact on performance. At the same time, shifting right also makes sense because you want to make sure that whatever you have as an infrastructure for a production environment or a pre-production environment is actually able to handle the load that you want to throw at it. So you can also use performance testing, maybe even on a copy of the production environment with the same infrastructure, with the same setup, to really figure out, okay, how much performance can we actually give, how much requests can we handle, when is it breaking, what is actually breaking. So in that scenario, shift right as far as possible. And the last one is chaos engineering. Again, shift left to have an idea of what actually goes wrong pretty early. So something like the key vault problem that we've seen, that is something that you can basically identify during development if you use a chaos experiment. But at the same time, if you have your production environment that has Azure Availability Zone redundancy, automatic scale up, all those fancy things that you can make, that you can do to hopefully get more resiliency in your application, you want to validate how that works. So once you have the trust built up and you have an idea of what Chaos Studio is doing and you know exactly what the experiments are causing, you might go so far as to maybe not during the most interesting hours of the day, but at some time actually run the chaos experiment on your production environment. But know what you're doing and always be ready to hit the cancel button. Okay, that's it. As a quick recap, what did we do today? We took a look at functional testing, make sure the application works. We took a look at load testing, make sure the application performs. And we took a look at chaos engineering for those weird problems that might pop up in case something goes wrong. We also saw automation on demand and continuously, and the products we used were Playwright, Azure Load Testing, and the Azure Chaos Studio. And I hope with that I gave you an idea of how quality assurance can work even outside of Business Central, gave you some food for thought, and also some instructions if you want to try this back at home so you can have a quick start. That's it for today. Now I would be open for questions. Yes.
Thank you. When you were doing the Playwright testing, is there a way to group set of actions that would be performed for every single one?
Yeah, you're basically in a full development environment, so it's TypeScript. So you could just put them into a function, a TypeScript function, and then call that in a loop or whatever. So you're open to do whatever you can do in a programming language.
The second part of the question is, we are selecting stuff by div name or stuff like that. How do we handle when Microsoft changes something?
Yeah, that's one of the reasons. I mean, I also try to use Playwright with Business Central, and that works surprisingly well, to be honest. But of course, for the things where you have dynamically generated IDs, like in Business Central, an approach like this takes a lot of effort to maintain. So I wouldn't go with Playwright. I'm actually very happy about the page scripting tool they presented, and I would very much advise to go for that instead for Playwright. Playwright is more when you have a more stable environment or the sources of the application are also under your control, so you can make sure you're not doing something that would make it almost impossible to test it. Further questions? Yes.
One of your testing concerning the Gmeter, you have created a file gmx which you uploaded within the load testing. I'm wondering if not sure really, is it possible also to create like a collection of API within Postman or within Insomnia and publish that to load testing in Azure and use that as a test?
Not that I know of, no. You either have the UI as you've seen where you can directly put it in, or you have JMeter. Of course, Postman or something like that would have the same kind of information. I didn't look for it. Maybe there is someone who can create from Postman a JMX file, but I haven't seen it. I think it's not natively there, but maybe there is an extension.
No, I mean, it doesn't have to be a GMX file, but I'm wondering if you create a collection of APIs requests and use that within the load testing.
Ah, okay. So you basically want to call a backend through what?
Through a collection of Postman.
You want to call a Postman script, Postman connection from a load test?
Yeah.
Yeah, I don't know. No, I don't think.
Okay.
I don't think so. Not that I'm aware of again. Okay.
Okay, thank you.
Other questions? Yes.
Hey, Tobias.
Hi.
Have you tried to run the page scripting part in Business Central using Playwright in a pipeline?
I don't think you need Playwright for that. I think they will come up with pipeline support directly. But yes, theoretically, you could use the Playwright. You could use Playwright to trigger the page scripting. I think it would be interesting to validate the results, and Playwright with Business Central is so-so. So I would rather wait for the pipeline support for the page scripting tool, to be honest.
You think that's on the backlog?
I at least heard so. Of course, I'm not
Okay.
Microsoft. I can't promise anything, but I heard so, yes. Further questions? Anyone? No. Then, again, thanks a lot. Have a good dinner and enjoy the rest of the conference.